Hello dear students. Today in this video I am going to discuss chapter 3 atoms and molecules. In the last two chapters we have discussed regarding the different types of matters and the properties of the particles of matter. And here we are going to see some more ideas regarding the properties of the particle of the matter. The particles are actually atoms and molecules. So the major topics we are going to discuss in these chapters are laws of chemical combination. There are two laws we will discuss under this topic. Then Dalton's atomic theory, the first scientific atomic theory was proposed by the scientist Dalton. Next we will discuss what is atom and the characteristics of atom, then molecules, then the third category particle, that is ions, then how to write the chemical formula of a substance, and how to calculate the molecular mass and the molar mass of a substance, and also mole concept. Out of all these topics, in this video I am going to discuss only these first 6 topics. The remaining topics, molecular mass and molar mass, also mole concept, I will discuss in the next video. So let's start with the laws of chemical combinations. There are two laws under this topic. First one is law of conservation of mass. Law of conservation of mass. And second one is law of constant proportion. So first let's discuss what is law of conservation of mass. It is stated that mass can either be created or nor be destroyed in a chemical reaction. Let's perform an activity to understand this very clearly. Let's perform the activity given in page number 31, that is activity 3.1. For that I have taken two types of materials like 5 ml of sodium sulfate as well as 5 ml of barium chloride. Both are chemical substance. Here 5 ml of sodium sulfate, here 5 ml of barium chloride. Okay, I am going to pour this sodium sulfate into the conical flask here. This is the conical flask. Okay, then I am going to pour this 5 ml of barium chloride into a test tube. Okay, then after that what I am going to do is that I am going to tie this test tube with this given thread. For that I am going to click on that one. So just tied it. Now I am going to hang this test tube in this conical flask. Okay, so for that I need to proceed with the next step. So while we hanging, it is very important to take the precautions that this barium chloride should not mix with this sodium sulfate. Clear? So I am going to keep in that one and close with a cork. Okay, now I am going to weigh this total mass of this substance or the whole setup on a weighing machine. For that clicking, so it is weighing. So what is the mass we got? 150.2137 gram. Okay, now this both chemicals you can see here in the test tube, barium chloride, and in the conical flask, sodium sulfate. Both are not mixed up. Okay, now I am going to take this conical flask and tilt it, then shake well, so that these two chemicals get mixed up. Okay, and keeping for 10 minutes. What will happen? Once it is get mixed up, there will be taking some chemical reaction. Now I am going to weigh this again. Okay, so what will be get? 150.2137 gram. Same mass. This was the mass we got when we measured before this mix-up, that means before the chemical reaction take place. And after the chemical reaction take place also we got the same mass. So what does it indicate? It indicates the result is given here, that is, so result is given here, since the mass of the total apparatus remains the same before and after the reaction, the total mass of the reactants is equal to total mass of the product. That means this law is verified. So we can state law of conservation of mass in a simple way, that is mass of reactants is equal to mass of products. Mass of products. Clear. That means in a chemical reaction, what will be the mass of reactant? The same mass will be after the reaction take place. Now, what is the second law state? That law of constant proportions. What does it state? It is stated that in a chemical substance, the elements are always present in a definite proportion by mass. For example, we take in case of water. What is the water? We know that chemical formula already, that is H2O. So the ratio of hydrogen to oxygen by mass, that means ratio of mass of hydrogen to the mass of oxygen in the water is equal to 1:8. That is fixed irrespective of the source of water. From whatever the source of the water, this will be the ratio. We know that what is the ratio in number? 2 hydrogen and 1 oxygen. Clear. So as this number is fixed, then obviously their ratio of mass is also fixed. Never think that here it is hydrogen 2, but in case of mass, hydrogen is less, because the mass of the hydrogen is smaller than mass of the oxygen. Okay, so you no need to worry about this particular number, why it is 1:8. We will be getting clear idea while we discussing the topic atomic mass. Okay, now we are moving to the next topic, that is Dalton's atomic theory. Daltons is the first scientist who given the basic idea of the atoms through his atomic theory. There are 6 postulates. First postulate is that all matter is made up of very teeny particles called atoms, and which participate in chemical reaction. So chemical reaction take place between atoms, and these teeny particles are called atoms. So in the chapter number 1, we have studied that all matters are made up of particles. Actually, that particles is named as atoms. That is a fundamental particle of matter. So he given a basic idea what is an atom, but he did not mention anything about the structure of atom. Okay, he just given all matter is made up of very tiny particles, that we can name it as atoms. The second postulate is that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms are indivisible particles according to him, but nowadays according to the modern study, atoms are divisible. Okay, we will discuss in the next chapter in detail. But at that time, while he was proposing this theory, it was considered as an indivisible particle because the fundamental particle, and which cannot be created nor be destroyed. It is nothing, it is just an alternate statement of law of conservation of mass. Because as the atoms cannot be created or destroyed in a chemical reaction, obviously the mass cannot be created and destroyed in a chemical reaction, because mass is actually because of the mass is constituted by the atoms of the substance. Clear? Then the third postulate is that atoms of a given element are identical in mass as well as in chemical properties. If you take 2 hydrogen atom, like 2 hydrogen atom, if you take, the mass of these 2 hydrogen atom will be same, identical. Also the chemical properties. For example, if you take hydrogen gas or particles from wherever part of the world, the both will be combustible, because combustibility, the high combustibility is actually the chemical property of both hydrogen gas or hydrogen particle or atom. And then the fourth statement is just giving that atoms of different element have different masses and chemical properties. As atoms of given element have identical in mass as well as in chemical properties, obviously atoms of different elements have different masses and their chemical properties. For example, chemical property of hydrogen and nitrogen are different. Next comes, that is, atoms combine in the ratio of small whole numbers to form compound. That is very important. Atoms combine in the ratio of small whole numbers. That is, we have to remember, to form compound. For example, we know that H2O, that is a chemical formula of the water. What is the ratio of the water as hydrogen to the oxygen in the case of numbers? 2:1. 2 hydrogen and 1 oxygen. But there is no such a possibility like that 1.5 is to 2 or 1.5 is to 2.5 like that, because atoms are indivisible, so atoms will be combined in the whole number ratio. We cannot make a compound of like 1.5 hydrogen and 2 oxygen or like that. So that is the fifth statement. And the last postulate, that is the relative number and kind of atoms are constant in a given compound. What does it means? It is nothing but just a modified form of law of definite proportions. Law of definite proportion. Because what is law of definite proportions is that in an element, in a chemical substance, the elements are always present in a definite proportion by mass. The same, then a relative number and kind of atoms are constant, definite in a given compound. So this is all about the Dalton's atomic theory. Okay. Now let's discuss some questions given in page number 32 and 33. What does it state that? In a given reaction, 5.3 gram of sodium carbonate reacted with 6 gram of acetic acid. Okay. So, and the products were 2.2 gram of carbon dioxide and 0.9 gram of water, 8.2 gram of sodium carbonate. Show that these observations are in agreement with the law of conservation of mass. So what we have to do is that we have to show this reaction is agreed with the law of conservation of mass. We need to show that the mass of reactants is equal to mass of products. So first we can write the mass of reactants. So here mass of reactants is equal to, what are the reactants here? Sodium carbonate and acetic acid. So what is the mass of sodium carbonate? Sodium carbonate is equal to 5.3 gram plus, what is the mass of acetic acid? 6 gram. Okay, which is equal to 5.3 plus 6 is equal to 11.3 gram. Now what is the mass of products? Mass of products is equal to, mass of product is equal to 2. What are the products here? Carbon dioxide, water and sodium acetate. Clear? So 2.2 gram of carbon dioxide. So here 2.2 plus 0.9 gram water plus 8.2 gram. So what is 2.2 plus 0.9 is equal to 3.1. 3.1 plus 8.2 is equal to 11.3 gram. Clear? So this is in agreement with the law of conservation of mass, because mass of reactants is equal to mass of products. Clear? You can write the statement. And what is the next question given? Question number 2. This is question number 1. And what is about question number 2? In question number 2, hydrogen and oxygen combine in the ratio 1:8 by mass to form the water. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen? So here ratio of hydrogen to oxygen is 1:8. Clear? That implies 1 gram of hydrogen reacts with 8 gram of oxygen. 8 gram of oxygen. Clear? Therefore, 3 gram of hydrogen needs 3 into 8 gram of oxygen, which is equal to 24 gram of oxygen. Very simple, direct proportion, just a concept of proportion, ratio. Clear? Because the ratio is 1 is to 8 means 1 gram of hydrogen needs 8 gram. Obviously 3 gram of hydrogen needs 3 into 8 gram, which is equal to 24 gram of oxygen. Some more questions are given that you can try yourself. Okay. Now next topic is the atom. What is an atom? Don't worry. In this chapter, we are not going to discuss too much details of atom. That will be discussed in the next chapter, structure of atom. Okay? Here we are going to look at briefly to what is an atom. This word atom has derived from the Greek word atomio. The meaning of this word is that uncuttable or non-divisible. During the development of the concept of atom, it was believed that atoms are uncuttable or non-divisible. But now, non-divisible and in chemical reaction, but that is still in chemical reaction, atoms are not divisible and uncuttable. But in nuclear reaction, there are some kind of reactions which we can see that nuclear reaction. You may have heard that in suns and stars, the energy is released with the help of nuclear reaction, like atom bomb. So in that case, atoms are divisible. Okay, but in case of chemical reaction, the normal reaction which takes place in chemistry, that is non-divisible. Okay, because of that, the word atom has given to this particle. You can state some characteristics of atoms, like it is the building block of. It is the building block of all matter. All the matters are made with these atoms. Whether it is homogeneous, heterogeneous, solution, colloid, whatever it is, all are made up of atoms. And it is the smallest particle. It is the smallest particle. Smallest particle which take part in chemical reaction. And it is the smallest particle of element. It is the smallest particle of element that displays all the properties of element. Why does it is mentioned like that? It is the smallest particle. I'm writing here. Smallest particle. So it is the smallest particle of element that displays all the properties of the element. Because the smallest particle which made matter is not atom, because you may heard like electron and protons. Electrons and protons are smaller than the atom because the atom is constituted by this one. But electron and proton do not show any property of that particular element. If you take a hydrogen atom, then it will show all the properties of hydrogen. That's why it is clearly mentioned that it is the smallest particle of element that displays all the properties of element. And generally this atomic radius are measured. Atomic radius are measured in nanometer. 1 nanometer is equal to 10 raised to 10 raised to minus 6. 10 raised to minus 6 meter. Sorry, minus 9 meter. Which is beyond our imagination. It will be equal to 0.0000 0 0 0 0 0 0 9 no? 6 9. It will be like this. Sorry, no, 1 0 will not be there. So this much smaller. Some prefixes we are using for smaller quantities as well as for greater quantities. For smaller quantities, for small quantities we are using like 10 raised to minus 1 will be deci. 10 raised to minus 2 is centi. 10 raised to minus 3 is milli. Okay, milli. And 10 raised to minus 4 and 5 usually we know. 10 raised to minus 6 is micro. Microorganisms are in this range. Then 10 raised to minus 9 will be nano. That we said already. 10 raised to minus 12. 12 is actually pico. One more we can say that 10 raised to minus 15, that is femto. These are the some prefixes we are using to represent small quantities. Because 10 raised to minus 2 is equal to centi. That means 10 raised to minus 2 meter is equal to 1 centimeter. 10 raised to minus 3 meter is equal to 1 millimeter. So in any quantity we can use this prefix. In case of large quantities we can represent like in case of larger quantities usually we use it to write like 10 raised to 1 deca. 10 raised to 3 is 10 raised to 2 we should not usually use like 10 raised to 3 is actually kilo. That is 1000 actually. Then 10 raised to 6 is actually mega. 10 raised to 9 is actually giga. Some frequencies of some waves we use to represent in this range. Okay, anyway, this is just for your understanding. I said we need to say that we need to understand only here that is 1 nanometer is equal to 0.1 raised to minus 9. That means atoms are very small. Clear? Usually the particles of solution will be in this range because most of the solution will be atoms. Okay. Now we are going to discuss how to represent an atom by using symbols. Okay. How to represent, how to give a proper symbol for atoms. That is quite difficult task because there are more than 100 elements right now we have discussed. It will be a little problematic because different people are going to give different symbol for different kind of elements. If they discover a new element, it will be a problem. So IUPAC, International Union of Pure and Applied Chemistry, IUPAC, International Union of Pure and Applied Chemistry. There is one international union. So they set up some certain rules to provide names as well as symbols for the particular element. Some of those we are going to discuss, not all the one. Okay. So first category, that is symbols of some elements are first letters of the elements in their name in English. For example, we can say that, see here, boron, B, first letter. In case of carbon, C is the first letter, C. In case of fluorine, F. In case of hydrogen, H. In case of iodine, I. In case of nitrogen, N. In case of oxygen also, O. In case of sulfur, sodium, sulfur is the S. In case of uranium, that is U. The second category comes, that is there in the first some elements are the first two letters of their name in English. Combinations of first letter, and first letter should be in capital as in the first case, and second letter should be in small letter. And the second letter should be a small letter. So you can see here aluminium, Al, first two letter Al, here also Al. Here argon, argon, and barium is the Ba, and bromine is the Br, and in case of Ca, calcium. In case of chlorine, it's not a cobalt. In case of cobalt, CO, first two letters, and in case of neon, Ne. Okay, in case of neon also it is possible, and the first two letters Ne, and in case of silicon, Si, and in case of yellow is not visible, no? Okay, and in case of zinc, others are not. And the third category, that is symbols of some elements are formed from the first letter of the name, okay, and a letter appearing the letter in the name. Letter in the name. What does it mean? In case of vowels comes after the second letter, it is going to happen. For example, you can see here chlorine, especially not necessarily always vowels, okay, in case of all the elements. Chlorine. In case of chlorine, after C, the next appearing letter is L. Chlorine. H is not appearing. Because of that, we are taking like that, Cl. Similarly, in case of any other magnesium, A is not appearing. Magnesium, M and G, magnesium. Because of that, we are taking writing as Mg. Similarly, any other zinc. In case of zinc, I is not appearing. Z and N, zinc. Okay, so it is written as Z. And the last category that comes, that is special kind of naming, like symbols of some elements have been taken from the name of elements in Latin, German or Greek. For example, iron. See here, in case of iron is representing as Fe. Why? Because the Latin word of iron is ferrum. Not English word, ferrum. So it is representing from that Latin word, ferrum. Similarly, in case of lead is actually plumber. Plumb. From this word itself, they taken P and P as the symbol for lead. Similarly, any other metal, gold. Gold actually ore. See, AU is taken from that. In case of potassium, it is calcium. Calcium. K is taken from that. And in case of silver, it is argentum. Ag is taken from that. Clear. And in case of sodium, it is natrium. Natrium. Na is taken from that. Clear. You can see Na. Here it is Ag. That is, there is no arbitrary method to give symbol. There are 4 different kind of elements. We are giving symbols by using different methods to avoid the confusion. Clear. So it is very important, that is table 3.1. It is given in your textbook. Very important, because we should know how to represent these elements, at least these elements in the symbolic form. Okay, while we are writing the chemical formula. Next topic under the atoms. About atoms we are going to discuss, that is atomic mass. We know that atoms are very small, teeny particles. Obviously its mass also will be very small. Because of that, a new unit is introduced for measuring the atomic mass, which is called AM, atomic mass unit. Now we will represent like a U, simply U, that is atomic mass unit. If it is going to convert this atomic mass unit into kilogram, 1 U will be approximately equal to 1.66 into 10 raised to minus 27 kilogram. This much smaller. Because of that, we introduced a small unit. How we introduced this unit? Because we consider that a carbon 12 as a standard reference. Then 1 U we consider it as 1 by 12 the mass of mass of C12 atom. Clear? Because carbon, the mass of carbon, we are consider it as atomic mass of carbon 12 is actually 12U. So by considering the atomic mass of carbon 12 as 12U, then 1 by 12th of that one will be 1 by U. So we are taking carbon 12 atom as a reference. Clear? Why it is specifically mentioned C12 means carbon has also some other type of carbon which is called isotope. We will be discussing in detail in chapter number 4. So this is all about atomic mass, and this is the unit measured for used for measuring the atomic mass. Let's see table 3.2 for getting of some atomic masses of some kind of elements that is here given here. That is atomic mass of hydrogen is actually 1U. That is, it is the lightest element in the world. Clear? Then carbon is 12, nitrogen is 14, oxygen is 16, sodium is 23, magnesium is 24, sulfur is 35, chlorine is 35.5, calcium is 14. So at least you study the atomic masses of these given elements. If the question involved in case of other elements, the atomic mass will be given in the question. Okay, so at least you have to study these atomic masses of the elements given in table 3.2, page number 35. Okay, then next topic we are going to see, that one is atomic mass of a molecule. So what is a molecule? We are going to discuss molecule. Molecule is nothing. A group of molecule is actually a group of two or more atoms. Group of two or more atoms are called molecules. Again, molecule we can classify into two. That is, molecules of elements as well as molecules of compounds. Molecules of element and molecules of compound. Molecules of compound. What does it make the difference? Is that it consists one type of atoms. Here it consists of different types of atoms. That is a difference. For example, in the atmosphere, oxygen gas, if you take oxygen gas is existing as O2. Similarly, hydrogen gas. If you take hydrogen gas is existing as H2, a molecule of two hydrogen. We can symbolically we can represent like this: H2, another molecule will be H2. Instead of independently existing, hydrogen gas exists as a group of two hydrogen atoms. That means a molecule of H. So this is not the correct way. Because of that, we will call it as molecule of element, which consists only same type of atoms. And in case of compound, that is very simple. For example, water. What is a molecule? Water molecule is H2O, two hydrogen and one oxygen. So it consists of different types of elements. So this is regarding about the molecules of elements and compounds. If you take the molecule of elements, that is, how many atoms are there in the molecule of oxygen and hydrogen? Two atoms. So we can say that atomicity of elements is the number of elements or number of atoms in a molecule of element is called atomicity of elements. So atomicity of oxygen is equal to, atomicity of oxygen will be 2 because there are 2 oxygen in the oxygen molecule. But sometimes oxygen possesses a special type of molecule, that is O3, we will call it as ozone. In case of ozone, this is O3. Ozone layer, ozone layer is actually the form of, it consists of the oxygen molecule as O3. That is a special case. But generally in the atmospheric oxygen, it is existing as O2. But while in case of atomicity of the compounds, we can say that, for example, atomicity of H2O. Atomicity of H2 is 2 hydrogen and 1 oxygen. So atomicity of H2 will be 3. So these are the two things we have to remember. And on the basis of the atomicity of elements are classified into different categories, especially the non-metals, because non-metals only we are discussing here, because in case of metals, they do not possess a certain molecular structure. It is different and it is little complex, so we are not going to discuss that. In case of non-metals like argon, helium, in argon and helium they are monoatomic because they exist as a single atoms. Argon and helium. Clear? While in case of oxygen and hydrogen, nitrogen as well as chlorine, they are diatomic because they exist as a O2, hydrogen as H2, nitrogen as N2, chlorine as Cl2. As diatomic because they are existing as a molecule of group of 2 atoms. While in case of phosphorus, that is tetraatomic, that means 4. Phosphorus existing as a group of 4 phosphorus atoms. In case of sulfur, that we will call it as polyatomic. Why it is polyatomic? Because it consists it is a group of 8 sulfur atoms. So solid sulfur exists in the nature as a group of 8 sulfur atoms. Because of that, we will call it as poly. More than 4 is there, we will, whether it is 5 or 6 or 7, we will together call it as a polyatom. Okay, so this is regarding the atomicity of elements. Now let's see another topic that comes under this section. Now we are going to discuss activity 3.2. Here there are 3 compounds given: water, ammonia, carbon dioxide. Okay. In case of water, what are the elements? Hydrogen and oxygen. Ratio by mass. Ratio by mass is given 1:8. We have to give. In case of water, we have to give. That is first one. Ratio by number we have to give. Ratio by number. In case of water, we already know that is 2:1 because 2 hydrogen and oxygen. Anyway, let's find in formal way ratio by number of H is to O. That is we have to find. For that, what we are going to do is that, what are the elements we have here? Hydrogen and oxygen. Okay, right here, hydrogen and oxygen. Then what is the ratio by mass of 1:8? What is our atomic mass? Atomic mass of hydrogen is 1 and atomic mass of oxygen is 16. Refer table 3.2 for atomic mass. Clear? Then mass ratio divided by atomic mass. So what is the mass ratio of hydrogen? That is 1. Clear? Divided by atomic mass of hydrogen is 1. 1 by 1 is equal to 1. Now what is the mass by ratio of oxygen? That is 8. Okay, divided by atomic mass is 16. So 8 by 16 is equal to 1 by 2. Simplified. Now see here, this one is fraction, another one is whole number. So what is the LCM of denominator here? 2. Here it is actually 1. Okay. So multiply it by 2, convert this fraction into whole number. So we will get 1 into 2, which is equal to 2, and 1 by 2 into 2 is equal to 1. See, so the ratio by number will be 2:1. Because we already know that the chemical formula is H2O, 2 hydrogen and oxygen. So if ratio by mass is given, we can find a ratio by number. Clear? That means ratio mass is given, we can find ratio of number. Clear? Now second one we are taking ammonia. In case of ammonia, what we can do? Ammonia consists of nitrogen and hydrogen. Ratio by mass is 14:3. So ammonia consists of nitrogen and hydrogen. These are the two elements. And its ratio by mass is 14 and 3. 14 and 3. And the third one is we will get atomic mass of nitrogen is 14 itself. What is the atomic mass of hydrogen? That is 1. Okay, just to refer this atomic mass we are writing in the atomic mass unit. Okay, just to refer the table 3.2, you will get a clear idea regarding this atomic mass of elements. Now 14 by atomic mass ratio will be 14 divided by 14, which is equal to 1. Similarly, here we will get a 3 divided by 1, which is equal to 3. Now it's already whole number, so no need of converting to whole number, just to keep us here. So the ratio will be, in case of ammonia, ratio is equal to ratio by number of nitrogen to the hydrogen will be 1:3. That is 1 nitrogen and 3 hydrogen. Because of that, its formula we will get NH3. Okay, don't worry about this formula. We will discuss how to write the chemical formula in the last section. Clear? So the carbon dioxide you can try yourself. Okay, I am giving to you. Next topic we are going to discuss, that one is ions. What are ions? Now we discussed molecules and atoms. Ions is nothing, charged atoms. Charged atoms or group of atoms. This is called ions. There are two categories of ions are there. One is anions as well as cations. Anions are negatively charged and cations are positively charged. Clear? Remember how this, you may be thinking that how these ions get charged. In case of neutral atom, that is in case of generally atoms are neutral. Okay, atoms are neutral. That is charge is 0. There is no net charge. Well, then how these atoms or molecules acquire charge? For example, we can take hydrogen. In case of hydrogen, one electron and one proton. We know that electron has negative charge as well as proton has positive charge. And these two, you will get clear idea about the electrons and protons in the next chapter. Okay, these are some particles contained in the atom. So electron has negative charge and proton has positive charge. Usually, generally in neutral atom, number of protons will be is equal to number of electrons. And if they even though if they have opposite type of charge, magnitude is same. For example, if you take the charge of electron as -1, then charge of proton will be +1. Strength of the charge will be same, but the sign is different. So in case of neutral hydrogen atom, 1 electron, so the charge due to electron will be -1 plus the charge due to proton will be +1. So -1 plus 1 will be 0. So the net charge or total charge will be 0. Because of that, neutral atoms, generally atoms are neutral in electrically. Suppose one electron is losing by this hydrogen atom. This negative charge will be deleted. So it will be having only positive charge. So it will acquire one positive charge. Now how this, that means it will become H plus cation. Now how hydrogen atom will acquire negative charge? Just imagine if one electron was there. So if just add one electron again to the hydrogen atom, what will you get? If it is electron is gained by the hydrogen atom, what will happen? 2 electrons. That means -2, the charge due to electron will be -2 plus the charge due to proton will be +1, which is equal to total charge -2 plus 1 will be -1. So the net charge will be negative. This is the way how atoms or group of atoms acquire negative charge. Okay, so this is the basic concept regarding the structure of atom. We will get a clear idea while we discuss in the next chapter. So don't worry about it. Table 3.6, that is very important. Let's see that table 3.6. See here, Table 3.6 consists of some symbols and charges of the elements. It's very important. Here one more term is given, that is valency. Valency is actually, it also represents charge. In case valency is a combining power of an element. Combining power of an element. That is called valency. For example, if we take water, H2O. In this case, oxygen react or combined with two hydrogen atoms. Clear? Oxygen combined with two hydrogen atoms. Because of that, we can say that the valency of oxygen is 2, because it has the ability to combine with the two atoms of valency 1. So because of that, we can see here oxygen, the valency of oxygen is 2. Clear? So this is regarding and also valency is representing the charge. Then in number, if we take the only the numerical value, valency and the charge are same. Clear? So there is a relation between valency and the charge. Atoms or group of atoms which has valency 1. See here sodium. Sodium always possesses positive charge. Potassium is positive. Silver is positive. Copper is positive. Copper possesses different type of charge. For example, copper 1 is there as well as copper 2 is there. Clear? So generally, similarly, in case of magnesium, in case of these all are metals actually, guys. Discussing. Okay, in the first column. In case of magnesium, Mg2 plus 2 positive charge. Here 2 positive charge, 2 positive charge. Iron also 2 positive charge. Copper is here. Copper second type is that is copper possesses different valencies. Okay, this is only for certain number of elements, not all for all the elements. Cu2 plus. They see here all are 2 plus charges, 2 positive charges because of its valence is 2. In case of the elements have valency 3, Al3 plus and Fe3 plus, iron 3, because here iron possesses 2 positive charge, here iron possesses 3 positive charge. Clear? And see, in these elements we have discussed, these all as positive charge. Am I right? Clear? Whether it is sodium, potassium, silver or whatever it is, these all elements have positive charges. You know why? What is the reason? Is there any similarity? Yeah, there is a similarity that these all are metals. So generally metals possess positive charge. Clear? If it is become iron. Clear? There will be a change in the number of valency or strength in the charge, but generally metals possess a positive charge. Clear? Now come to in case of non-metallic elements. What is happen? You can see here hydrogen. Hydrogen, if it is H plus, if it has one positive charge, it is named as hydrogen. There is no change. Clear? Like, is there any change? We are naming it as a sodium, potassium, like that. While in case of negative charged ions, we will not name it as the name of the element. We will make some changes. Very simple. If hydrogen acquire one negative charge, we will not call it as hydrogen. We will call it as hydride. One De, IDE will be added. In case of chlorine, chloride. In case of bromine, bromide. In case of iodine, iodide. In case of oxygen, oxide. In case of sulfur, sulfide. In case of nitrogen, nitride. They have different valency and different charges, but all these non-metals have negative charges. So generally metals possess positive charges and non-metal possess negative charges. That is the one conclusion we can get from this one. And next, the last one we are going to see, that one is polyatomic ions. That means the ion which consists of more than one type of atoms or one atoms. For example, NH4 is there, okay, sorry. In this table, ammonia is actually NH4, okay. This small correction here, NH4. You can refer to table 3.6 in your textbook, page number 37. Clear? So NH4 plus, that is ammonia. Similarly, OH we will call it as hydroxide, hydrogen and oxide. So it is together, we will call it as hydroxide. In case of nitrate, NO3 together, which consists of 3 oxygen atom and 1 nitrogen atom. So this group of atom, that is this polyatomic ion, we will call it as nitrate. Then hydrogen carbonate, that is HCO3. One more is the carbonate, that will be only CO3. If HC, hydrogen also included, that will become hydrogen carbonate. The next is sulfite. Sulfite means which have 1 sulfur and 3 oxygen. Which are sulfite, but sulfate is 1 sulfur and 4 oxygens. The both are different, okay? Don't be confused about it. These all are charged. This all possess 2 negative charge. The up one is charge, okay? Down one is number of atoms. And here, one positive charge, one negative charge, negative charge, negative charge. And in case of last one is phosphate, 1 phosphor and 4 oxygen. The charge of this phosphate is 3 minus. Remember the charge as well as the symbol of this atomic ions as well as these polyatomic ions to solve the to write the chemical formulas. Clear? Okay. Now the last topic we are going to discuss, that here it is how to write the chemical formula. We already discussed what is valency, so we are not going to discuss again. The certain rules to be followed while we writing the chemical formula. First one is valency or charges. Both are all number wise, they are same. Ion must be balanced. Second one is when a compound consists of metal and a non-metal, the name of the metal or symbol of the metal is written first. That is the second rule we have to remember. And the third rule we have to remember, that one is in compounds formed with polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of ion in a bracket and writing the number of ions outside the bracket. Leave it. We can take the example so that we will get a clear idea. I'm going to discuss some questions given in page number 39. So let's see what are these answers of this question. Write down the chemical formulae of the sodium oxide, aluminum chloride, sodium sulfide, magnesium hydroxide. Very simple. So for that, first I am going to take sodium oxide. What is the symbols of sodium here? Symbols and valency. Valency or charge, okay. In case of ionic compounds, it will be charge. So symbol we can write the sodium. What is the symbol of sodium? That is Na. Okay. And what is the symbol of oxygen? Oxide is actually oxygen. Clear. So what is the charge of Na? That is charge or valency, that is 1. Oxygen is 2. Then just cross this one to balance it. What you will get? 2 Na. Okay. That is Na2 and 1 oxygen. So this is the chemical formula. Na2 is the Na2O is the chemical formula of sodium oxide. Let's take one more example, that is aluminum chloride. What is the symbol? Symbol and valency or charge, okay, whatever it is. In case of aluminium, symbol is Al. And in case of chloride, what is the symbol? Cl, chlorine. What is the charge or valency of aluminium? 3 and chlorine is 1. So just across this one we will get Al1, okay, Al1, Cl3. 1 no need to mention, so we can write AlCl3. That is a chemical formula for aluminum chloride. Similarly, you can try sodium sulfide, magnesium hydroxide. Sodium sulfide you can try. I am taking this magnesium hydroxide. In case of magnesium hydroxide, third one. Okay. In case of option 3, magnesium hydroxide. What is the symbol of magnesium? Symbol of magnesium is Mg and hydroxide is OH. What is the charge of magnesium? The charge of magnesium is actually 2 or valence is 2 and OH is -1, that is 1. Just cross this one. What do we get here? Mg1 OH The third rule will be coming here. In case of compounds formed with the polyatomic ions, the number of that polyatomic ion should be written outside the bracket. That means this polyatomic ion should be kept in a symbol. Clear? So we can simply write it as 1 is not needed. So Mg OH. OH should be kept in a bracket, 2 should be outside. This is we have to follow in case of polyatomic ions. So I hope you understood how to write the chemical formula. Now let's discuss one more question given in the same page. First one, I'm not going to discuss all the one. First one I'm going to discuss here. Option 1. Al2 SO4 thrice. SO4 thrice. What is the chemical name of the compound will be? Al is aluminium. Aluminium. What is SO4? No need to look at this number, only this one. SO4 is sulfate. Aluminium sulfate. Clear. Similar way you can try the other options. Now the third question I am not going to discuss. Fourth one is how many atoms are present in H2S molecule? How many atoms are there? 2 hydrogen and 1 sulfur. That is 3 atoms. In PO4 ion, how many atoms are there? 4 oxygen and 1 phosphorus. So that will be 4. So I hope you got a clear idea. You just try yourself to solve the questions given in the textbook so that you will get a clear idea about these topics. And also those tables given in the textbooks are very important regarding the symbols as well as charges. In the next video, I will discuss the second part, that is molecular mass, molar mass and the mole concept. Okay. So thank you.